Right, so we looked at these two equations. We're just going to label them and put some units on. This Q is a value of energy measured in joules. This is the mass of substance being heated, usually water. Okay, usually H2O. Okay, and that's measured in grams. This is your specific heat capacity. And usually that's water, and usually that is 4.18 times 10, 4.18 joules per gram per Kelvin. Okay, and what that is telling us is that you require 4.18 joules of energy to heat up 1 gram of water by 1 degrees Kelvin. So we're running out of space here, but this is our temperature change. Okay, and that can be a positive increase or it can be a negative decrease depending on if it's exothermic or endothermic, and the units we use for that are Kelvin. Okay, so first equation. Second equation, to work out the delta H, what we do is we standardize the amount of substance used. So we standardize that by using a mole. So whatever value of energy was released or taken in during this calculation, we then divide it by how many moles was used. So this here is our enthalpy change. Okay, now first thing to note is that this is in kilojoules per mole. So rather than it being in joules here, it's in kilojoules, so we need to convert the joules into kilojoules by dividing by 1000 before we get onto this calculation. Q is from over here, which is the energy change, this time in kilojoules, and this here is going to be the number of moles of, and this is the important part, the limiting reagent.